Well, I told you that the two most important things you should know in thermodynamics, and that'll get you most of your way through most exams, is that the pressure times the volume is equal to a constant, and that the pressure times the volume divided by the temperature is equal to a constant. And so they all change such that the initial pressure times the volume times the initial divided by the initial temperature is equal to the final pressure times volume divided by the final temperature, assuming that you're not changing the energy of the system, and we'll do more on that later. And the other thing you should remember is that pressure times volume is equal to N, where N is the number of moles, right? Mole is like a number like dozen, but mole is a huge number, 6 times 10 to the 23 times R. R was the universal gas constant. That's 8.21, I think, times, let me see what, I just forgot it. I think it's 8.21 times 8.31. This is 8.31 joules per mole Kelvin times the temperature. And remember, whenever, just to be safe, always convert to Kelvin first. So let's see if we can do a problem that I can make up on the fly of this situation. Let's say I have a balloon. And the volume of the balloon is, let's say it's 1 meter cubed. So this is a big balloon. That's fairly large if you imagine a cubic meter. So the volume is a cubic meter. Let's say the pressure is equal to, I don't know, let's say there's not a lot of pressure in it. So it's the pressure is equal to 5 pascals, and that's newtons per meter squared, right? And let's say we're at a reasonably warm temperature. So temperature is equal to 20 degrees Celsius. So my question to you is and let's say that balloon is filled with helium. So my question to you is, how many molecules of helium do I have in the balloon? Well, let's just substitute into the equation. So we have pressure, which is 5, and I'll actually write the units. I never do it, but you should, and you should always do it in an exam. 5 newtons per meter squared times volume, 1 meter cubed, is equal to my number of moles, N, times the universal gas constant, 8.31 joules per mole Kelvin, times temperature. And remember, I can't repeat this enough, always convert the temperature to Kelvin. So whatever our Celsius temperature is, add 273. So add 273 to that, you get 293 Kelvin. So let's see. I get 5 times 1, and meter squared, meters cubed, this cancels out. This just becomes a meter. Newton meter is joules. 5 joules is equal to N moles times 8.31 joules per mole Kelvin. Well, this Kelvin and this Kelvin cancel out. So 8.31 times 293. So let's see. 8.31 times 293 is equal to 2434.83. So let me write that down. Times 2434.83 joules per mole. And so to get the number of moles, we just divide both sides of the equation by that, and the units should work out. So you get 5. So N, switch colors to ease the monotony. N is equal to 5 joules times 1 over that, 1 over 2434.83, and then since we're dividing by this flips, moles per joule. And then, of course, this joule cancels out with this joule, so we just have to divide 5 by this, and we'll get the number of moles. So let's take the inverse of what I had there, times 5. So I get 0.002 moles. So this equals 0.0021 moles. Now that might seem like a small number to you, but let's figure out how many molecules that is. So we already said, we knew that, let me make some space free, because I'm going to write some Avogadro's number down. So let me get rid of all of this stuff. Okay. Now I have space. So Avogadro's number. Did I even say what Avogadro's number is? Avogadro's number is the number of molecules per mole. It's that number. So number Avogadro is equal to 6.022 times 10 to the 23 molecules per mole. So that's the top is molecules, the bottom is mole. I know you can't read that. So if I have 0.021 moles, how many molecules I have? Well, I just multiply that 0.0021 times how many moles per molecule, right? Because this is moles. Let me write that down. Moles times Avogadro's number molecules per mole. I know that's molecules. This is mole. Maybe I should write the whole thing. Molecules per mole. So then the moles will cancel out. And Avogadro's number is 6.022 times 10 to the 23. Let's just remember that. And let's just multiply that times 0.0021. It equals 0.02. So this equals, let's see, 0.0126 times 10 to the 23, right? We have to remember that. Molecules. Let's see, this is 0.0126. That's the same thing as 1.26 times 0.01, right? And then, of course, times 10 to the 23. And what's 0.01? That's 10 to the negative 2, right? 10 to the negative 1 is 0.1, so this is 10 to the negative 2. So then we get 1.26. 10 to the negative 2 times 10 to the negative 3, we add the exponents, times 10 to the 21st power. So roughly 1, 2, 6, and then another 19 zeros, or roughly 1 followed by 21 zeros, is how many molecules of, in this case, helium we had in the balloon. So not too difficult. The hard part is really just remembering Avogadro's number, remembering the universal gas constant is 8.31 per joules per mole Kelvin, remembering to always convert your temperature to Kelvin, and then just making sure all your units match up. I mean, sometimes they might be tricky. They might give volume in liters, and you have to, especially in this case, you have to convert it to meters cubed before you do it, or they might give pressure in atmospheres, or bars, and then you should know the conversion and convert it to pascals or newtons per meter squared. But other than that, it's just substituting and just doing the hairy math and the scientific notation. Anyway, hopefully that was vaguely clarifying. See you in the next video.